Okay, so now we've looked at the inverse of when it's x squared. Let's look at when it's an exponential function, f of x equals x squared. Okay. So, and not, we'll call it, it's normally, an exponential function is normally sort of a to the x. F of x equals a to the x. So let's give a value of 2. It's the least we've got numbers that we can put in.
Okay.
So an exponential function always is intersected at 1, because 2 to the power of 0 is 1, because anything to the power of 0 is 1. Okay, and then
right.
if we have x being a negative number, so say x was -1, if x was -1, then we would have, because of our exponential rule, the 2 goes to the bottom and becomes +1. So 2 to the -1 is a half. So as x becomes negative, you actually get this where it gets smaller and smaller. 2 to the -2 would be 1/2 to the 2, which is a quarter. So we're getting smaller and smaller and smaller on this side. But it never actually touches, because no matter what x is, x could be x could be minus a million. It'll just be 1/2 to the minus 1/2 to the million, which is just a very, very small number. So we actually have an asymptote, which is y equals 0. So let me do that. I'll do that. So we've got this asymptote. Actually, let's just do it in yellow. So this is our asymptote, y equals 0.
Okay.
Okay. And I'll just make a note of that. Okay. And when you make x1, it becomes 2. When you make x2, it becomes 4, 3, 8, and it obviously gets huge, massive on this positive side. So if we were to draw the graph, it would look like that. So that's our exponential graph, f of x equals.
Yeah.
So now let's do our inverse. So the first step in finding the inverse of a graph, so what is f to the -1 of x, say. Okay, so the first thing we do is we swap x and y. So rather than write f of x, we just write y and then we swap them.
Okay.
So y just becomes x. And x just becomes y.
Yeah. So x is 2 to the power y.
Yeah.
Okay.
Okay, so we've swapped them. Let me actually do the colors differently because, oh no, that is right. Now we want to get y by itself. So we need to use logs.
Yeah.
So remember the rule for logs. Let's just put log. I'll do that in white. Log base number equals exponent. You just got to remember this whenever you're wanting to do logs. Just remember this rhyme. Log base number equals exponent. Log base number equals exponent. Because then you can think of the base. The base is like a tree. It always has something at the base of a tree has like leaves on top. And the exponent, well, that's just the thing on top of the base. And then the number we can think of as a number by itself. So this here is crucial in logs. So let's apply that rule here. So we've got log base, the base is 2.
Yeah, base is
Number is
2.
the number by itself, which is x.
X.
And that is equal to the exponent, which is y. And so we have, when we have an exponential graph, the inverse, which you asked to get, is the log graph. So y equals just going to do log 2 to the 2 to the x. Okay, so now what you can do is we can put in some values. Well, one of the things when we're dealing with an inverse is because we're swapping x and y, you always have an asymptote that's been swapped. So your asymptote for your y equals x graph, sorry, y equals log 2 to the x, is just x equals 0.
Oh, okay.
So often they'll ask you, what's the asymptote of this graph? And you sit there trying to work it out. Don't worry. The asymptote of an inverse graph is the opposite of the original graph. So if you've got y equals 0, in that first case, we've got x equals 0 as our other asymptote. So we know that it's not going to cross the line. The other thing is when we swap x and y, our numbers are coordinate swap. So let's just look at this coordinate here. This coordinate here was 0 and 1.
0 and 1.
So we just need to find the coordinate 1 and 0. So that's there.
Oh, wow. Okay.
And I'm pretty sure it's either going to come from this way or from this way. Well, the easiest way, I mean, you can put it in your calculator, but because you never know, we might get some log questions in that question 1 of the paper. Let's make x equal 2. So then we've got log, from our log laws, we can say log 2 over log 2. Because this one, I'll just draw them in different colors so we can see. So this 2, you can write as a 2. Yeah. And this 2 represented this one. And so we can just cancel to 1. So we're
okay.
Y is 1. Okay. So now I'm confident that I can just draw my, oh, sorry, wrong color. We want it in pink because the inverse is the one in pink. So like that. Okay, so that's my inverse graph. And this is a wonderful illustration of how you can, it goes across it is about the line of y equals x. How it's a perfect mirror, because this is the graph of, I'm going to do that in a different color. What haven't I used? This one. It didn't allow me to do that. Nope. Okay. Well, it's in. Let's do this. Okay, so there's the line of y equals x. And we can see that x and y, it's flipped about that line of y equals x. So we can see how y and x were swapped.
Yeah.
Okay, so that's a couple of, so the tips for the inverse graph. First thing you do is swap x and y. Then make y the subject of the formula. Then you also know that any points, any points on the graph, if it's 0 and 1 or 3 and 1, can just be swapped. So 3, 1 would become 1, 3 in the inverse graph. And the other thing is the asymptotes are swapped as well. So in a nutshell, inverse functions, you swap x and y. Then the only thing you could just got to be careful of is things like in the previous one where we had a exponential function, and then when you had the square root, you couldn't get the square root of a negative. Okay, so
yeah.
this is exponential graphs. When you swap them, you get a log graph.